In this video, I'm going to show you how to solve special limits involving sine. There's one key fact that we're going to be using as we do these limits, and that key fact is that the limit as x approaches 0 of sine of x over x is equal to 1. Now, this limit is not entirely obvious because, first of all, if you sub in x equals 0 just into the limit, you get sine of 0 over 0, which becomes indeterminate form of 0 over 0. Also, proving this limit actually takes more math than we're comfortable with at this point. But that's okay, we'll learn how to prove it later. For now, let's just focus on computing limits which look similar to this given limit. So now we want to compute the following limits. First of all, limit as x approaches 0 of sine of 3x divided by 2x. Now, of course, the first route to go is always direct substitution, but again here, direct substitution gives us sine of 0 over 0, and sine of 0 is 0, so this takes indeterminate form 0 over 0. So what can we do? Well, let's try to get the limit to look like this given limit as much as possible. So right now we have a 3x inside of the sine, so why don't we try to lump that all into a single variable, say u. So we'll make a substitution, u equals 3x, and why don't we just go ahead and solve for x in terms of u while we're at it. So x would equal u over 3. Okay, so this limit here is equal to the limit as x approaches 0, well x is just u over 3, so limit as u over 3 approaches 0 of sine of 3x, and 3x is just u, over 2x, and x is just u over 3, so this is 2 times u over 3. Alright, so this might look actually a little bit more complicated, but that's okay, we can simplify it further. First of all, notice that in order for u over 3 to approach 0, the numerator u has to approach 0. So this is just the same as the limit as just plain old u approaches 0 of the same stuff inside. Now let's go ahead and pull out whatever is multiplying the u on the bottom. We've got a 2 and then over 3. So this is like 1 over 2/3 times this fraction sine of u over u. Now 1 over 2/3 is just a constant, so we can factor that outside of the limit. 1 over 2/3 is just the reciprocal of 2/3, which is 3 over 2. So this becomes 3 over 2 times the limit as u approaches 0 of sine u over u. Okay, so now we're in the place that we want to be. We've got a sine u over u as u approaches 0. That's equivalent to this limit up here. It's just phrased in terms of a different variable, but it really takes the same form, so it has the same value. The value is just 1, so this is just 3/2 times 1, which is just 3/2. So there we go, that's the value of the limit, 3/2. Alright, moving on, the limit as t approaches -1 of sine of t plus 1 over 3t plus 3. And again, if we try to substitute in t equals -1, we get sine of 0 over 0, which is 0 over 0, which is indeterminate form. So we have to do some manipulation first. The way we're going to do the manipulation is, again, we're going to try to reduce it to this limit fact up here. So what we need to do is we need to condense that t plus 1 inside of the sine into a single variable. Why don't we call it u again? So we'll let u equal t plus 1. By that same token, we have t equals u minus 1. And then we'll just go ahead and substitute in here. So this will be the limit as u minus 1 approaches -1 of the quantity sine of t plus 1, and t plus 1 is just u, over 3t plus 3, so 3 times t is just u minus 1, and then plus 3. Alright, so now let's go ahead and simplify this limit a bunch. So first of all, the limit as u minus 1 approaches -1. In order for u minus 1 to equal -1, u has to equal 0, so this is the limit as u approaches 0. Another way to see that is that as t approaches -1, if we sub into this expression here for u equals t plus 1, if we sub in -1 for t, we get u equals 0. So either way you look at it, u is approaching 0, and then we've got of sine of u over, let's distribute this product, 3u minus 3 plus 3. And we see that our minus 3 and plus 3 cancels out, so we've just got limit as u approaches 0 of sine of u over 3u. Now let's put some finishing touches on this. First of all, we'd like this to just go to sine of u over u. We want to get rid of that 3, and the way we get rid of the 3 is we just factor it outside of the limit. We can do that because it's a constant. Now that's in the denominator, so it's really 1/3 that we're factoring outside of the limit. 1/3 times the limit as u approaches 0 of sine of u over u. And we already know that the limit as u approaches 0 of sine of u over u is just 1. So 1/3 times 1, that equals 1/3. So there we go. That is the value of our limit. Next up, we've got some more limits. First of all, we want to compute the limit as x approaches 0 of tangent of 2x over x. If we try direct substitution here, we get tangent of 0 over 0, and tangent of 0 is just 0, so we get 0 over 0 indeterminate form. That doesn't help us. But let's see if we can rearrange the limit a bit so that we can simplify things. In particular, we want to see if there is a sine of variable over variable limit hiding in this expression, because we know that kind of limit goes to 1. That's the limit fact that we know from the previous slide. So why don't we go ahead and unpack this tangent here. Remember, tangent is just sine over cosine. So let's go ahead and write it as such. So we have the limit as x approaches 0. We'll write this as tangent of 2x times 1 over x. And tangent of 2x is just sine of 2x over cos of 2x, and then that's times 1 over x. Alright, so one thing to point out here is that it's just the sine term and the x term that are causing our problems with indeterminate form. Sine is going to 0, x is going to 0. Actually, the cosine is not causing a problem at all though, because cosine of 0 is just 1. So what we might try to do is we might try to separate the limit across multiplication. We'll get that cosine in its own limit and get that sine over x in the other limit. So let's go ahead and do that. So separating out the cosine first, we have limit x approaches 0, 1 over cosine of 2x times the limit as x approaches 0, sine of 2x over x. Alright, so limit as x approaches 0 of 1 over cosine 2x. That's easy, we just plug it in. Cosine of 2 times 0 is cosine of 0, which is 1. So this becomes limit of 1 over 1, which is just 1. The second limit is a bit tougher, but we know how to deal with this from previous problems. All we really have to do is lump this 2x into a single variable, call it u. U equals 2x, and then we'll have x equals u over 2. Okay, so let's sub that into this limit. This becomes the limit as x approaches 0. Well, as x approaches 0, if we plug x equals 0 into this expression for u, we find that u approaches 0 also. So u approaches 0. And then sine of 2x, well, 2x is just u, so that becomes sine of u. And then x is just u over 2. So that's what we have in the denominator, u over 2. Alright, so this is 1 times that limit, so it's really just this limit. Limit as u approaches 0. We've got our sine of u up top, that's all good. But this u over 2 in the bottom, we want to get that to just u. So we'll go ahead and factor that over a half out of the bottom. So we'll just have u and then times 1 over 1/2. We'll move that constant out, 1 over 1/2 in front of the limit. 1 over 1/2 times the limit as u approaches 0 of sine of u over u. Now 1 over 1/2 is just the reciprocal of a half, which is 2. So this is 2 times the limit as u approaches 0 of sine of u over u. That limit is just 1, as we know. 2 times 1, that's just 2. So there we go, that's the value of the limit, it's 2. On to the next limit, the limit as theta approaches 0 of 1 minus theta over theta cosecant theta. Alright, so what if we try direct substitution on this limit? If we try direct substitution, we get 1 minus 0 up top, so just 1 up top, and then theta is 0, so 0 times cosecant theta. Cosecant theta is just 1 over sine theta, so 1 over sine theta would be just sine of 0, which is 0. And 0 times 1 over 0 is indeterminate form. So we still have indeterminate form for this limit. So what do we do? Well, why don't we start off by trying to simplify the limit so things can cancel, or so that we introduce a sine of theta over theta somewhere. So first thing here, we're going to take the limit as theta approaches 0, and we'll clean up this limit a little bit by canceling out that cosecant theta term. So what we really need to do is we need to express it as 1 over sine theta. And now that we've done that, we see that we can cancel out that 1 over sine theta by multiplying by sine theta over sine theta. Alright, so sine theta on the bottom cancels with this 1 over sine theta, and then the expression becomes limit as theta approaches 0 of 1 minus theta times sine theta all over theta. Now why don't we go ahead and separate this limit to isolate that sine theta over theta part, because we know that simplifies to 1. So let's go ahead and do that. This becomes the limit as theta approaches 0. First of all, we'll have 1 minus theta, and then times the limit as theta approaches 0. The rest of the numerator, sine theta, then over theta. Now this first limit here, we can just directly sub in theta equals 0 into the expression 1 minus theta. We do that, and we just get 1 for the limit. And then the second limit here, sine theta over theta as theta approaches 0, we already know that just takes the value of 1. So the overall limit is just 1 times 1, which is 1. Great, so now we know how to solve special limits involving sine using the fact that the limit as x approaches 0 of sine of x over x is equal to 1. In the future, we'll learn how to do a similar thing with a special limit for cosine.